So just to give you a little bit of a lead-in, we've been teaching a course on batch process design, which is populated by fourth-year undergraduates and first-year graduate students. And the stimulus for the course was a number of the companies that have hired our students who do batch processing have been, over the years, concerned that the students really aren't exposed to batch topics. And so that's why we created the course. And if I can just get this first slide to work. So the motivation was really that the way the curriculum is currently structured, there's really very little time for discussion of batch. It's basically continuous focused, and yet there's a significant industry sector, including pharmaceuticals, that is, shall we say, dedicated to the batch mode. So the idea of this course is really to cover basic, what are the features of the batch operating mode, what are some of the common unit ops, and how do they differ from the steady state. And then I do like to end the course with a little bit more of a focus on getting students to think of batch processing as not just a collection of unit ops, but actually these are production lines and should be thought of as processes just as we do in the continuous setting. So that's kind of the motivation and objectives. So the DynoChem case study is, exothermic reaction, isothermal, fed batch, minimize time to make desired amount of feed, manipulate feed rate. The only twist we do on the DynoChem model, we tell them they only have a maximum volume of reactor. We remind them that heat transfer area changes with level. And then we throw in this constraint of maximum allowable temperature rise if the cooling system fails. So the notion is if something goes wrong, the reaction will continue, and how far that reaction will continue depends on how much B there is left in the unit. So it complicates life just a little bit and makes the problem a little bit more interesting. So we use the DynoChem fed batch reactor model. The version we use, we just modified it to include that MTSR constraint, and they enter the parameters and then carry out the case studies. And one could define a whole series of different case studies. That's a very nice, convenient feature of using DynoChem. The math is taken care of. All they really need to do is to think about the cases that are worthwhile to examine. So it makes it nice. And one of the nice features of DynoChem is it does give them nice ways of displaying whatever they want to look at in a very convenient fashion, and that's nice. Now, the kind of feedback we've got, the students really like is the spreadsheet structure. It's, all of our engineering students get exposed to spreadsheets, use of spreadsheets and MATLAB in the freshman year. So this is very convenient for them. They like the fact that they can see everything, that they can plot easily, and then cases are easy to run. From an instructor point of view, it's great that they don't have to worry about the numerics. We want them to know what's going on, but we don't want to have them spend time on those kinds of details. So the objective of the course is really to expose them to batch and fill a gap in the curriculum. People don't cover batch in the standard curriculum, partly because there isn't enough time, partly because the math complexity is a bit higher. So it's easier to deal with simpler models than it is with general dynamic models. And in most chemistry curriculum, the places where dynamics is treated is in the control course, and that occurs typically in the last year. So I personally like using DynoChem for purposes of this course, because again, the purpose of the course is to focus on batch and its characteristics rather than worrying about the numerics. And so it provides a pretty low entry barrier tool for students to be able to study these operations and see through graphics what goes on. As I mentioned before, I like the fact that we can focus their attention on the fact that data is going to be needed for these unit ops, and so the data generation is a very important part of development of a process, and I like the fact that DynoChem team has chosen to introduce those kind of capabilities.